Hello and welcome to this screencast on the adjacency and incident matrix of a graph. So I'm going to go straight ahead and just draw a simple graph, and this graph has 4 vertices. So just to recall, a graph is simply, now I'm going to label these vertices A, that's more like a D, A, B, C and D. Okay, so if you recall, a graph is a set of vertices which are joined by a set of edges. So each edge joins 2 vertices. And I've just made up this graph off the top of my head. Okay, so straight away I'm going to start to talk first about the adjacency matrix. Now, an adjacency matrix has the same number of rows and columns as vertices in your graph. So in this case, we have 4 vertices, so we're going to have 4 rows and 4 columns in the adjacency matrix. Okay, each row of the adjacency matrix corresponds to one of the vertices, and this likewise with the columns. So I'm just going to label columns ABC, rows ABCD, and columns ABCD as well. Okay, so what the adjacency matrix is if 2 vertices are adjacent, and by that I mean they're connected with an edge. For example, here A and B are adjacent because they're connected by the edge AB. We put a 1 in the adjacency matrix corresponding to the row of one vertex and the column of the other. So in this case, AB, I'm going to put a 1 in here. Okay. In addition to AB, AC is also an edge. So we've got an edge joining A and C. Therefore, A and C are also adjacent. So here's my row corresponding with the vertex A. So I also put a 1 next to AC. Okay, well, in the element corresponding to AC. Okay, finally, D, as you notice down here, A is not adjacent to D. There's no edge joining A and D. So I'm going to put a 0, okay, in that element. Okay, so I've done the first row. Just to make things easy, you might notice, but we could a vertex is never adjacent to itself in this case. Okay, so we haven't got any edges looping around back to D here. So on the main diagonal, I'm going to just insert zeros. So A is not adjacent to A, B is not adjacent to B, and so on and so forth. Okay, so let's move on to the next element, B. Okay, well, B is adjacent to A, so I put a 1 in here. B is adjacent to C, so I'm going to put a 1 in here. And finally, B is also adjacent to D, so I'm going to put a 1 in here. Okay, that's the vertex B done. Move on to the vertex C. C is adjacent to A, so I'm going to put a 1 in here. C is also adjacent to B, so I'm going to put a 1 in here. And finally, C isn't adjacent to D. There's no edge joining C and D, so I'm going to put a 0. Okay, and lastly, D. The only vertex, but D is adjacent to is B. So it's going to be all zeros apart from the B column, which is 1. Okay, and that's the adjacency matrix for this graph. You might notice the adjacency matrix, or this one, is symmetric. Now this is a general rule for all adjacency matrices, because they're always square, they're also going to be symmetric. Okay, this moves on to the incidence matrix now. Now the incidence matrix is slightly different. We start by forming a matrix with the same number of rows as we have vertices. Okay, so in this case I'm still going to have 4 rows. Now with the incidence matrix, each column represents an edge. Okay, so we loop through, well, we go through all the edges, and we put a 1 next to the vertices which the edge joins. Okay, so in this case, if I take the edge AB, I have an edge AB, so if going down the column, this edge joins A to B and no other vertices. Okay, so in this case, this column defines edge AB. Okay, let's move on to AC. I have the edge AC here, so in the next column, I have a 1 next to A, a 1 next to C, and zeros for B and D. Okay. For this edge here, joining B and C, I have a 1 next to B, a 1 next to C, and zeros next to A and D. And finally, this edge here, B and D, so this edge joins B and D, I have a 1 next to B, a 1 next to D, and zeros in the other two elements. Okay, and that's the incidence matrix for this graph here. So incidence matrix doesn't always have to be square. It is square in this case because we have 4 edges. But the thing to remember about incidence matrix is each row represents a vertex and each column represents an edge. Okay, so I'm going to have a look at a further example. Just going to scroll down a bit. I'm going to define another graph. This one's slightly more complicated. So just try and make it a bit more complicated than what we've seen before. So I'm going to start off by just drawing a cloud of vertices. I'm going to join these vertices up with some edges in a minute. So okay, what we have here, D, E, F, and G. Okay, so let's just make up some edges. Oh, I'm going to draw that edge again. So A to F, C to F, A to C, why not? A to D, D to F, I'm going to have F to G. And what I'm going to make this graph here, I'm going to make it unconnected. So you notice we have some vertices which aren't connected to the main graph here. Okay, so as we start with the adjacency matrix, so I have 1, 2, 3, 4, 5, 6, 7. So I'm going to have 7 rows. So I have 7 rows in my adjacency matrix. Okay. And I'm going to have 7 columns. I'm going to label the columns as well. Okay, so start with vertex A. A is not linked or not adjacent to B, so I put a 0 there. A is adjacent to C. Likewise, it's adjacent to D. It's not adjacent to E. It is adjacent to F, and it's not adjacent to G. Okay, so that's the first row done. And also A isn't adjacent to itself. Okay, second row, B is not adjacent to A. Also, it's not adjacent to itself. And the only one B is adjacent to is actually E. So it's going to be 1 in the E column and zeros elsewhere. Okay, vertex C. C is adjacent to A. C is not adjacent to B. And the only other element, vertex it's adjacent to is F, and all the others are 0. Okay, D is adjacent to A and F. So A and F are going to be 1s, and everything else is going to be 0. E, that's meant to be an E down here, I just tidied up a bit. E is only adjacent to B, so we're going to have 1 in the B column and zeros elsewhere. F is adjacent to C, A, D, and G. So A, C, D, and G, and we're going to have zeros elsewhere. And finally we have G, which is only adjacent to F, and zeros elsewhere. Okay, so that's the adjacency matrix of this graph. So it's a 7 by 7 matrix because there are 7 vertices, and as you can see, it is also symmetric about the main diagonal. Okay, that's the adjacency matrix. What about the incidence matrix? Well, remember the incidence matrix has 7, or in this case has 7 rows, because there's the number of vertices, F and G, and each column is going to represent the edges. How many edges do we have here? So we have 1, 2, 3, 4, 5, 6, 7. Oh, this is also going to have 7 edges, just by coincidence. Okay, so the first edge, let's say AC. So I have an edge joining A and C, and therefore I have zeros in all the other rows. So that's my first edge. I've got an edge joining A and F, so I have A, 0, 0, 0, 0, 1, because that corresponds to F, and a 0 at the bottom. A to D, so I have a 1 next to A, 0, 0, 1 next to D, and all the others are 0. Okay, C to F, so I have a 1 next to C, 1 next to F, and got zeros elsewhere. D to F, okay, so I've got a 1 next to D, it's about there, 1 next to F, and I have zeros elsewhere. F to G, so 1 next to F and G, zeros elsewhere. And finally, B to E, so a 1 next to B, and a 1 next to E, and zeros elsewhere. Okay, so that's the the incidence matrix for that graph there. And one final thing about the incidence matrix is if we want the degree of a vertex, now a degree is a number of edges which intersect the vertex. So in this case, A has 3 edges, there, there, and there. That can be found by summing the row of the incident matrix corresponding to that vertex. So in here, we sum the row of A, we can see 1 plus 1 plus 1 is 3. So the degree of vertex A will be 3. Okay, and that's adjacency matrix and incidence matrix of a graph.